All right, hey guys, Mr. Kyle Myers Mathematics, and let's just jump right into it. This is solving systems of equations by elimination. So when we do elimination, what we're trying to do is eliminate. Yep, that's what we're trying to do. We're trying to get rid of one of the variables. It doesn't have to be both. It normally isn't. It can sometimes be. We might come across a problem or two where that happens, but typically that's not what happens. Typically the goal is you focus on either the X or the Y, or if you're using other letters, use the other letters. Whatever the letters are, focus on one of them and have one equation have the negative of that and the other equation have the positive. So like good twin, bad twin, right? So for instance, if you're going to focus on the x's, then you want one of them to be like negative 2x and the other one to be 2x. Or 3x, well then the other one would be negative 3x, right? And so on and so on. So if you're focusing on, y, it would be the same thing except you replace x with y or whatever your letters are. I think they use x's and y's all throughout this worksheet. Okay, so if it's already set up for you, like it's going to be for the first few here, then you kind of just add them up. Kind of just add on both sides, and then that's it. And then you just solve, and you're good to go. When we get to where it's not already like that for you, then we'll cross that bridge when we get there. But for right now, we're already good to go, because if you look, we've got the x is right there, the y is right there, and the numbers are right here, right? Everything is in nice little neat columns. Negative 4x plus 4x. I don't know what x is. However, negative 4 times something plus 4 times that same something, that's the same number. Not, ignoring the minus sign for a second. If you ignore the minus sign, it's like, okay, 4x and 4x, like that's the same thing, no matter what x is. X could be 5. Okay, well then it would be 20 and 20. 20 minus 20 is 0. So no matter what x is, it would be 0. All right, so the x goes away. The x does not go away unless the numbers are exact opposites, though. So in order to do elimination, the coefficient, the number multiplied by the letter, has to be the exact opposite of the other one, and it is. So they cancel. This one doesn't, though, right? So 8y minus 2y is 6y. That equals negative 12 plus negative 24. They're both negative, so I'm going to add them up, and I get negative 36. Right? So I add them up, and I get negative 36. And then I'll want to divide by 6. So my pen didn't want to work there for a second. There we go. All right, so then we divide by 6. Y is going to be equal to negative 6. Okay, are we done? No, because they said to solve the system. When they say solve the system, they want x and y, or whatever your letters happen to be. Okay, so because we have y, we're almost done. You might say we're halfway done, but we're kind of more than halfway done, because once you solve for one of the letters, the rest of the letters are easier to get. The hardest part is to get the first letter. The rest of the letters kind of follow in line. And I say the rest of the letters because sometimes you might solve a system where you've got 3 equations and 3 variables. Usually not more than that, but I mean, theoretically it could be. So how do we solve for x, though? Because we already just used both equations. Well, just because you used both equations doesn't mean you can't go back and use one of them again. Let's say negative 4x minus 2y equals negative 12. All right, so we'll copy and paste it over here, and then just plug in my y value. Now, if you're already a little bit more advanced, you might be like, oh, well, you could divide everything by negative 2 and make your life a little easier. Yes, you could, but I'm trying to keep things pretty simple right now. So I'm just plugging into the equation as is. All right. So before anybody tries to school me in the comments. Although I'm sure if I make a mistake, somebody eventually will let me know and be like, hey, you messed up on problem 4. And I'll be like, oh, yeah, I guess I did. Thanks. And they'll be like, you suck. And I'll be like, well, can't be right 100% of the time. They're like, oh, well, I can. My YouTube channel is better. Okay, cool. Have a nice day. Bye, Felicia. All right. So anyways, so number 2. Same thing, actually, as number 1. Because if you look at it, it's a 4. It's almost the same thing. That's really weird, actually. How it's like almost, isn't it? It's kind of weird. All right, I'm not going to do the lines this time. 4x minus 4x cancels. 8 plus 2 is 10. 20 minus 30 is negative 10. Divide by 10, divide by 10. Negative 10 divided by 10 is negative 1. And then I can plug it back into one of the equations. Let's say I want to plug it back into the first equation again. This time I will show you what I was referencing earlier. So if you want to make your equations a little simpler, if all of the numbers divide by something, a greatest common factor, you can divide by that, or just divide out by something. It doesn't necessarily have to be the greatest common factor. Just divide by something that they all divide by. And that actually makes the numbers smaller, and then that makes your life a little easier. However, don't divide by something unless all the things can divide by it, because otherwise you're dealing with fractions now, and that's much worse. So all of these numbers divide by 4. So I can divide this side by 4 and this side by 4. Okay, sorry, I keep scratching my eye. Itchy eye. Okay, 4x over 4, that's going to be x. And then 8 over 4 is 2. 20 over 4 is 5. And then it's just a little bit easier to deal with. So yeah, I mean, it's an extra step, but it makes the numbers a little bit nicer. I don't know, kind of hit or miss. You don't really have to do it. I don't think it's super necessary to do that. So x minus 2 is equal to 5, and then I'm going to add 2 on both sides. Boom, 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 boom. X equals 7. Okie day. Oh, I forgot to box my y. All right, and there's number 1 and number 2. Let's keep going. Numero 3. So I'm going to start to go, I'm going to do like a little bit less of the showing of my work on each problem as we go here, until we get to where it's like a little bit more complicated, and then I'll go from there. So this is x plus 2x, right? 1x plus 2x is 3x. Negative y plus y cancels. 11 plus 19 is 30. Divide by 3. X is 10. Okay. Let me do this. All right. And then we plug it back in. So I'm going to plug into the first equation again. So 10 minus y equals 11. Subtract 10 on both sides. Careful with that. You're not adding. If you were moving the y over, you'd be adding y on both sides, but we're not. We're wanting to get rid of the 10. I guess you could add the y on both sides, but that would be an extra step. Well, actually it wouldn't in this case. It wouldn't be an extra step in this case, but it is what it is. 11 minus 10 is 1. So positive y is equal to negative 1. All right, cool. Over here, it looks like those cancel, the x's. 5 plus 4 is 9. 1 minus 10 is negative 9. Divide by 9. Y equals negative 1. And then we plug that in. Negative 6x plus 5, negative 1 equals 1. So that's negative 6x minus 5 equals 1. So I'm going to add 5 to both sides. X equals negative 1. They both equal negative 1. All right, cool. Let's switch to a different color, because why not? I'll move my arm, because I had my arm resting right where the little fan thing was blowing, and my arm was super warm. Okay. Come on. Why is it not? There we go. All right. Probably user error. Here we go. Number 5. So now we finally come across a problem in which the coefficients, the numbers that are multiplied by the letters, are not opposites. Now, I mean, they're pretty close, but they're not opposites. They are the same. The y's are, at least. So, excuse me. Because the y's are the same, we're not too far away from having them be opposites. All we have to do then is, because they're both the same sign, I just need to take one of the equations, not both, just one, and multiply it by a negative. So let's do the first equation. Plus, plus, plus. If I multiply everything by a -1, it flips the sign, so all the negatives become positive. Now the y's will cancel, because that's 9y minus y, or 9y minus 9y, which is 0. All right, 2x minus 4x is -2x. And that's going to be positive 25 minus 23 is 2. X equals -1. All right, then I plug it back in. Plug it in, 2x plus 9y equals 25. -2 plus 9y. I'm going to add 2 to both sides. And then divide both sides by 9. And there we go. All right, x equals -1, y equals 3. Okay, next one. We have the same problem. The y's both don't have a number. Well, they don't have a number that we can see in front of the y's. If there is no number in front of the y, it's not 0, it's 1. Ones are ninjas. If you don't see a number, it's probably a 1, not a 0. Sometimes it can be a 0. Like if you want to add a number, but you don't want to like add, you know, a number that's going to change the equation, then you could always add 0. There are some cases where you would want to put like a +0. But usually the number that's hiding from you is a 1. So in this case, it's a 1. Both of them are 1y positive, so I need to make one of these equations negative. How about this one? Change the sign of everything. Okay, so now this is plus. 8 plus 3 is 11. Y minus y is 0. -16 plus 5 is -11. X equals -1. All right, then I plug it back in, Okay, -8. And then I add 8. And there we go. Okie dokie. I'm gonna make a little division line there. Try to keep my work fairly neat and spaced out and whatnot. All right, we got the same thing going on here again. So I'm gonna change the signs. Change, change, change. Don't forget to change all the signs, not just the signs that you want to change. Otherwise, your equation has changed, and then you're not going to get the correct answer. All right, -6x plus 6x is 0. 6 minus 3, right? So that's going to be 3, so 3y. 6 plus 12 is 18. Y is 6. Plug it back in, I can take the first equation and divide everything by 6. If I do that, I get -x plus y equals 1. I could have also divided everything by a -6, but it's whatever. So subtract 6 on both sides, and I would get -5. That's going to be 1 minus 6. And then divide both sides by a negative. X equals 5. Oh, by the way, I don't know if I really have space, because I just barely have space to write it out and like solve it the way I'm doing it now. But if you do have space, maybe on one of these last ones, I'll show you this thing where you can check to make sure that your answer is correct. If there's a way to check it, you never want to check your answer, by the way, by just resolving it the same exact way you did it the first time. Because if you made a mistake, you'll more than likely make the same mistake by trying to check it and solving it the same way you did last time. You want to check it by doing something different, either solving it a different way, so like using a substitution method instead of elimination method, but that's still a long way to check it. There's a faster way to check your work that doesn't involve doing a whole different method, and I'll show you that in a little bit, but I want to make sure I have space. So Let's change the signs of everything in the bottom row. You could change the signs of everything in the top row, and that would be fine also. But let's do bottom row just because. 7 minus 8 is negative 1. 2's cancel. 24 minus 30 is negative 6. So x is 6. Would have been better to change the top row, I think, but it's all good. Speaking of top row, let's take the top row. It seems like it has smaller numbers, generally speaking. 7, 6, 2y, 24. 7 times 6 is 42, the answer to life, the universe, and everything. And then we want to subtract 42. Menos 42 on izquierda y derecha. 2y igual. And then we go 24 minus 42. This one's a little weird because it almost seems like it'd be like, oh, like 4 minus 2. But you always subtract the bigger one into the littler one when you're thinking about subtraction. So even though it's 24 minus 42, it's actually going to be a little bit better for us if we do it this way. However, if you do 42 minus 24, you're going to get a positive number. Subtraction normally is supposed to be the larger positive and then the smaller negative, right? A bigger number minus a smaller number. When you have 24 minus 42, that's kind of like flipped around. The 42 is the thing that you're minusing. So you're going to end up with a negative. However, the cool thing about subtraction is, yes, it's not the same thing if you flip the order, right? So 24 minus 42 is not the same thing as 42 minus 24. It's not what I'm trying to say here. But they are exact opposites of each other every time. So 24 minus 42 is the exact opposite of 42 minus 24. So it's still helpful to do 42 minus 24 instead. Okay, so with that said, if I'm subtracting 4 from 2, you have to carry a little bit, right? So you're imagining like, okay, how many is this away from 2 or 12? And that would be 6 spaces to get to 10, 7, 8 more, so 8 total spaces to get up to 12 if we borrow, which means, right, if we're borrowing, then we borrowed there and we got 12. So 4 is 8 spaces from 12, and then 3 minus 2 is 1. So that's 18. So our answer then is negative 18. All right, that was kind of long, but I was explaining how to do it. The process here is actually pretty nice. So if you have trouble with your negatives, try this out and see if it works for you, okay? If you're already good to go with your negatives, awesome, but most of you are not, okay? I've tutored a lot of people in over 10 years of tutoring, and everybody from Algebra 1 to Calc 3 makes mistakes with their negative signs. Okay, so do not underestimate the power of negativity. Negativity can really bring you down, okay? So we want to be careful with those negatives. All right, negative 18 divided by 2 is negative 9, and then that's going to be the answer for that one. All right. Speaking of negativity, negative signs are actually one of the most common ways to miss a math problem. One of 5 that I came up with. I came up with a list of 5 things. It's called the 5 math mistakes everyone makes and how to avoid them. Go grab it. It's for free. It's on my website, myersmathematics.com. Link in the description below. And I'll go ahead and finish up here. I think I'll just finish up with these because I think there's a whole nother set. Yeah, there's a whole nother set. But these take a while to do. So I think we'll go ahead and finish up with these 4 here. So if you're watching this and this is an older worksheet, then I'll already have the other set done. So you'll be able to go and just continue on with the next half in the next video. If you're watching this and it's less than a week old, then I have not yet posted the second half. So stay tuned. All right. Here we end up with a slight problem compared to what we've got previously, because this is the first time that the x's and the y's both, we don't have anything where they're opposites. But in the last few, we also, all we had to do was change the sign of something and then we can get things to cancel. Now we can't do that either. You have 5x and 10x. Doesn't matter which one you make negative. There's not going to be exact opposites of each other. And then with the y's, it's y and negative 7y. It doesn't matter which one you change the sign of. They're not going to be opposites of each other because the coefficients, the numbers multiplied by the letters, don't match. Right? This is the trickiest, one of the trickiest. This is still not the hardest type of elimination. it gets worse. So what we have to do, a couple things actually, two thoughts. The first thought, the simplest thing to do would be to just times each equation by the first number you see. Meaning I would times this first equation by 10, since the second equation has a 10 in the front. And then I would times the second equation by 5, since the first equation has a 5 in the front. So the simplest thing to do is to times the equations by each other. Basically, like the leading number of the other equation. Okay, that's the simplest thing to do. Is that the best way to do it? Not usually, but it's the simplest because it always works. It's a method that always works. And then, of course, make sure that one of them is negative and one of them is positive. You got to have them be opposites of each other. Okay, what I'm going to do here is I'm going to do this. I could multiply the first equation by 7, and that would make the y's cancel. Okay, that would work. If I multiply the first equation by 7, I'd have 35x. So the x's still don't cancel. But then I multiply the y by 7. Now I've got positive 7y. And then the y's would cancel. 7y minus 7y. That would cancel. So I could do that. I could multiply the first equation by 7, and that would work. However, you want to play this smart. Okay? This is where it gets kind of hard. You could multiply by 7. That would work. However, I can multiply by a smaller number, 2. Negative 2 to be exact. And that also works, and that's a smaller number, so it's easier to do the math, right? Work smarter, not harder. You ever heard of that? We want to work smart here, because it's already hard enough as it is. If I multiply the first equation by a negative 2, negative 2 times positive 5 is negative 10. Negative 2 times positive 5 is negative 10. So negative 10x plus 10x, that would cancel. That's easier, it's less work, because I'm multiplying by 2 instead of 7. Okay, so I'm going to do that. So negative 2 times 5, that's going to be negative 10x. Negative 2 times y is negative 2y. Negative 2 times 9, negative 18. All right, and then I just kind of copy paste the next one. There we go. All right, negative 2y minus 7y is negative 9y. Negative 18 minus 18 is negative 36. Divide, divide, boom, boom. All right, so then negative 36 divided by negative 9 is positive 4. And there we go. So then I just do what I've done in the past. At this point, it's the same as all we've done up to this point. Okay, so I just plug it back into one of the equations. The first equation looks like it's simpler, so I'm going to plug it in there. Plug in 4. All right, and then I'm going to subtract 4 on both sides. Divide both sides by 5. And there we go. All right, cool. Moving on. I could multiply by 3 and get the y's to cancel, or 4 and get the x's to cancel. 3 is smaller than 4, so I'm going to choose to multiply the second equation by 3. Okay, so then that's going to be negative 4x plus 9y equals 9. I'm keeping the first equation the same. I'm going to multiply the second equation by 3. 3 times x is 3x. 3 times 3 is 9, so that's minus 9y. 3 times 6 is 18, so that's negative 18. Right, that's going to be negative x. Y's cancel. 9 minus 18 is negative 9, so x is equal to 9. All right, and then I just plug it back in. The second equation is has smaller numbers, so I'm going to plug it into the first equation, or sorry, the second equation. X is 9, so that's 9 minus 3y equals negative 6. Minus 9 on both sides. And then divide both sides by negative 3. And there we go. All right. Last two for today. Here we go. I think that's a 7. I think that's a 7. If it's not, let me know. But I think that's a 7. So this would be hard. If I wanted to make the y's cancel, they don't have anything in common. They don't have any common factors. So if I wanted to make the y's cancel, I would have to multiply the first equation by 5 and the second equation by -7. And you might have to do that. That could be a thing you have to do. I don't have to because there's an easier way. If I choose to try to eliminate the x's, all I need to do is multiply the first equation by -3. Okay, and that'll work. That'll work just fine. So let's do that instead. So 9x minus, and assuming that's a 7 there, that would be -21y. And then 3 times 16, 48, I think. -9x plus 5y. The other thing too is that so far, all of these equations have been lined up. Meaning we have the x's are first, then the y's are next, equals, and then the numbers. They're in the exact same order every time. They don't have to put these equations in order for you. That would make it harder, but that's something they could do. So just a heads up on that. 21 minus 5. All right, notice that's not what it says, but that's what I said. -21 plus 5 is the opposite of 21 minus 5. Remember, it's always going to be easier to subtract naturally. Right? Isn't it easier? As soon as I said 21 minus 5, you're like, wait, yeah, that would be much easier. But can I do that? Yes. Yes, you can. However, if you have to switch the signs to make it natural, a natural subtraction, right? Which is like a bigger number minus a smaller number. Natural subtraction. If you have to switch the signs to make it natural subtraction, just don't forget to switch the signs back. This method works really well. You just have to remember to not forget to switch the signs back. So 21 minus 5, what would that be? That would be 16. So this is going to be -16y. And then that's 48 plus 16, which, what is that going to be? 4, 5, 6, 64? Yeah, 64. Okay, and then 16, 16, and then what is that? I think that's 4, -4? -4? Yeah, these are some big numbers here. We could have maybe simplified things. Maybe not. Wow. Yeah, these are just big numbers. Okay, whatever. It's fine. And then we'll just plug it back in. They both have big numbers. I don't know. Let's do the bottom one since it's already right there. -9x plus 5, y is -4, equal to 16. -9x minus 20. Okay, add 20 to both sides. That's going to be 36. X is -4. All right, I do think that was a 7 because so far all of the answers have been integers. So I think if that wasn't a 7, I would have probably gotten like some weird, fractions or something going on. So I'm pretty sure that was a 7, but let me know if it wasn't. All right, and then 12, which is the last one for today. Okay, looks like if we wanted to eliminate the x's, we'd have to multiply them by each other. Meaning the first equation I would multiply by 2, the whole thing. And then the second equation I would multiply by a -7, because remember I need them to be opposites also. Okay. However, it's going to be easier to take the first equation and multiply it by -3. Okay, so let's multiply it by -3. Well, then that would be 3 times 7 is 21 minus 3y. And then 3 times 19. Man, they're really making me think here. I'm actually not that good with like my multiplication tables. So give me a second here. 2, 7, 3, 3, 5, 5, 57. Okay. 57. Let's see. Okay, so -2x plus 3y, -19. All right, so 21 minus 2 is 19. And that's going to cancel because we want it to, because it does. 57 minus 19. Yeah, that works. Okay. Boom, boom. That's 2. Okay. And then I'm also going to do this. I'm going to kind of make a little divider right here. Because I do want to check this one. I did say I was going to show you how to check them to make sure that they're right. In case you want 100%. 100%. Here's how you do it. So actually, let's do this. We'll kind of put a little divider here as well. All right. And then we're going to plug into the first equation. And then I'll leave some space further here. I'll show you. So this is over here is where we'll check. Okay, so we're going to plug it in. So -7. Plug in my x. Plus y equals -19. This one's actually really good to plug in anyways because I don't really have to divide anything to get y. Plus y. Add 14 to both sides. I don't know why I'm showing that I'm adding 14 on both sides. I guess just because I have the space. I don't know. -19 plus 14. It's going to be -5. All right. So this is what I get. Okay. So I normally would be done, right? Here's how you check. Here's how you check. What I just did in order to get my second letter. So in order to get my second letter, not my first letter, because I had to kind of combine the two to get my first letter. I chose the first equation to plug in my my x into to get y. Okay, so because I chose the first equation, I check with the second. If you use the second equation to get your second letter, and finish up the problem, then you would check it with the first, right? So you check with the equation you didn't just use. You wouldn't plug in to the first. You plug it in to the other one. Okay, so since I used the first equation to finish up the problem, I'm going to use the second equation to check. Right, so -2, plug in x, plus 3, and plug in y. Okay, and this is how you check. -2 times 2 is -4. 3 times 5 is 15, so that's -15. And what is that going to be? That's going to be -19. That's how you check it. Okay, when you are checking it, plug it into the equation you did not just use to finish the problem. The other equation, plug in both the x and the y, and make sure that the left side equals the right side. If it does, it worked. If it doesn't, then you did something wrong. Now, I mean, it could be that you checked it wrong. That's always possible too. But most of the time, like 95+% of the time, it means that you did something wrong in solving for x or y. Okay. Also, if you're allowed to use a calculator, use a calculator. Use the tools that are at your at your advantage. If you're allowed to use a calculator, it's even easier to check these because you just plug everything in on the left-hand side into your calculator, and then just it would spit out -19, and you're like, oh, okay, that equals -19, so I'm good to go. So it's actually even less work if you have a calculator. So definitely recommend that. If you want to get a good grade on your upcoming test or quiz, I would highly recommend checking at least the hard ones, at the very least, if not all of them. All right, and with that, we are done. Again, I was saying that we were going to do the first half. Let me get my finger ready on the end button over here. So that's the end of the first half, and next week we'll pick up on the second half, and you can stay tuned for that. I will kind of pick up where I left off in the sense of I'm not going to start off super slow like I did with this one. I'm going to kind of sort of pick up where I left off, not show every single step because I just don't have the space. I won't have the space for it, so I'll just have to start off pretty much at about the pace that we left off here. Okay, so if you're watching the second one and you still kind of need to get the basics down, start back at the beginning of this one, rewatch it, or shoot me an email. I always have my email in the description below as well, because I do tutoring. So just let me know if you need some help, or you can just kind of send me the question that you're on. Whatever works, just whatever works. I'm here for you guys. So, all right, without further ado, that's it. Hope to see y'all in the next video. Have a blessed one.